So, good day everyone. We are here, the group 5, to discuss to you our topic for today, which is the solid, liquid crystals and its intermolecular forces.
Liquid crystals, a substance that exhibits phases that have properties and intermediate between those of a crystalline solid and a normal liquid and possess a long-range molecular order but still flow. They change shape like a fluid but have the molecular alignment and characteristics of a solid crystal. Liquid crystals, anisotropic structures which exhibit different properties when viewed from different directions. Possess long-range molecular order but still flow like fluids. Long, rigid molecules that can interact strongly with one another. In intermediate phases, nematic, sematic, cholesteric, the molecules have an ordered arrangement and yet can still flow like a liquid. Liquid crystals tend to consist of rigged molecules with polar groups, and their anisotropic structures exhibit unusual optical and electrical properties. Liquid crystals are anisotropic. Their properties depend on the direction in which they are viewed. Hence, liquid crystals are not disordered as a liquid because the molecules have same degree of alignment. Properties of liquid crystals. Properties of liquid crystals like solid. Orderly arrangement of particles. Bound by stronger forces. Molecule is layered, arranged in a random position. Optical activity. Anisotropic and scattered light. Properties of liquid crystals like liquid. Fluidity. Molecular mobility generates fluidity. Viscosity, cloudy appearance. Surface tension, break the orientational symmetry at the interface. Most substances that exhibit the properties of liquid crystals consist of long rigged rod or disc-shaped molecules that are easily polarizable and can orient themselves in one of three different ways. Ikaw na.
So, in the mnemonic phase, only long axes of molecules are aligned, and the ends are scattered in random intervals. In sematic phase, the long axes of the molecules are parallel, and the molecules is also arranged in planes. Finally, in cholesteric phase, the molecules are arranged in layers. Each layer is rotated with respect to the ones above and below it to give a spiral structure. The molecular order increases from the nematic phase to the sematic phase to the cholesteric phase, and the phase become increasingly opaque. Molecules that form liquid crystals tend to be rigid in polar groups and exhibit relatively strong dipole-dipole and dipole-induced dipole interaction, hydrogen bonds, and some combination of both. In most cases, the intermolecular interaction are due to the presence of polar and polarizable groups, aromatic rings, and multiple bonds between carbon and nitrogen or oxygen are especially common. Moreover, many liquid crystals are composed of molecules with two similar halves connected by a unit having a multiple bond. Last but not the least, because of their anisotropic structures, nematic liquid crystals exhibits unusual optical and electrical properties. For example, it is tend to relatively translucent, but many of them become opaque when an electric field is applied and the molecular orientation changes. And for the note, intermolecular interaction includes in all terms which are responsible to rate the orientational symmetry in the surface.
That's all. Thank you. Group 5.